So I would like for you right now to write down the major topic for the day. The major topic for that, right? What is it? What are we talking about? Energy. It's a word that you have been using, sometimes accurately, sometimes a little bit inaccurately, from a physics perspective, throughout your year, throughout your life, all of those sorts of things. What I'd like for you to do right now, just to kind of like, we're just going to do like a big brain dump real quick. Write down all the kinds of energy you know of. Go. This is you and your brain. Don't talk, don't talk, don't talk. You and your brain. Types of energy, go. Question. Yep, I know. And then I found it. Yep. That's all you're using. Yep. What kinds of energy have you heard of? What do you know of? What is energy? I'm not grading you on this list, but I do want you to write down, as I said, as many as that you know of. I'll give you another, 10 seconds. You've heard this word. You've used it before. Okay, I'm going to give you, 45 seconds, a minute, something like that, to talk to your table mates. Make your list longer. Put your brains together. Make your list longer.
Wait, so there's thermal radiation.
I was like,
Yes, dear.
I wrote
Wait, what's that?
Right? And I get energy from Oh, you guys are awesome. I love it. All right, my friends. I want to make a really big list. So, Gunnar, I'm going to start with your table. Tell me a kind of energy. Just one. Thermal. We're going to just go around and around and around and around and around. So make sure you're listening and paying attention. We're going over here. Nick, what you got? Kinetic.
Name one.
Sure.
Electromagnetic.
Electromagnetic. I know, right? Go.
Solar. Boom.
Go.
Potential.
Speaking of covering lots of bases. Key in your group?
Nuclear.
Oh, come on. Thank you for saying that well. That's one of my biggest pet peeves as a physics teacher. I'm going to pause there just to clarify. I want you all to say it with me. Nuclear.
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 If you say that, I kick you out.
What did he say?
He said it incorrectly.
Nuclear.
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 Nuclear. Nuclear energy. All right. Thank you very much. Go. Chemical. All right, back here. Tell me anyway. Radiation energy? So radiation.
I mean, thermal is also electromagnetic.
Yeah, we're going to get there. We'll get there. Go. Elastic. Go.
What's it called? What's left? Right.
It's up here. That's why you're paying attention. Do you want us to come back to you? Okay. All right. Tate, do you guys have more?
Is it an elastic one?
No.
Okay, hydrodynamic or something.
Ooh.
No? Hydroelectric.
Is that okay? Can I change?
Hydro something.
Yeah, go. Okay.
If you can't name one,
Go. I'm just laughing because Ellie's laughing, that's all.
Every time. Yeah, I'm starting to write other people's.
That's okay.
So.
Do you guys have more?
No.
No?
oh, you just got these.
What's up? Quick. We gotta go fast. What? Wind, yeah.
Solar. Can you give it to us?
Sound? What you got?
Internal. Reset
Okay.
Light. We'll count it.
Go. That's okay. I just want to exhaust all of our choices here. What else we got? Brianna's got one. What'd you say? Biomass. More? Gravitational? You can, but I'm going to ignore you. Yeah.
Wait, why can biomass be up but not ATP?
What else you got? Anything else? It's okay.
Where should put it up?
ATP, yeah. Man-made. It's just man-made.
All right. Let's pause because I feel like we're kind of at a stopping point. So, I want you to look at this list. Now, there are some nice ways that you can kind of parse this list out into kind of categories, right? So, lots of different ways to. The way that I would like to break it into categories is to look at two in particular, and I think I would argue that we can put all of the rest of them into one of those two categories. Anybody know what those two are, the ones that I'm thinking of?
Kinetic and potential.
Kinetic and potential, that's it right there. And those are the ones I want you to put boxes around. All right. So, if you do not have those two written down, then you need to write them down. If you have them written down, put boxes around them or something like that. We need to define them and tell us what we mean. Okay? Kinetic. What does the word kinetic mean? We've met that word before this year even. When did we do it? We were talking about it in terms of friction. We talked about kinetic friction as opposed to static friction. And the kinetic friction was the friction that was involved when something was moving, right? Kinetic energy is the energy of motion. Okay? Most of you have probably heard this stuff many, many moons ago in another science class, right? Probably. And if you haven't, we're going to do it right now. But if you have, I mean, this is one of those things that they often do in elementary and in junior high and that kind of thing. So we're going to do this real quick. So this is, kinetic is the energy of motion. If something is moving, then it's got kinetic energy. Potential is kind of the opposite of that. Potential is the idea, and I'm sure none of you have heard this from your parents. I'm sure it's not the case. I'm sure there are other kids who have heard this though, right? You know, you have a lot of potential. And if you would just blah, 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 right? Get your butt off the couch or apply yourself in math or blah, you know what I'm saying? Whatever it is, you could do it, you just haven't yet, right? The word potential in an energy context means that you have, it's stored energy, it's energy due to position or composition, okay? We talk a lot about a kind of a continuum, energy switching from kinetic to potential or vice versa. So you can think of potential as we got this stored up energy, and if we just do something to it, we can turn that into this energy of motion or backwards, right? Okay. The big wind turbines take kinetic energy and they turn it into potential energy, okay? And then a motor takes potential energy and turns it back into kinetic, right? A turbine and a motor are opposites and they do the exact opposite thing. So what I'd like you to do right now with your team, with your table, is to take a look at the rest of these types of energy, and I would like for you to classify them either as kinetic or potential. I will tell you that there are some that can be argued multiple ways, and I don't want you to get in big fights. So go through. I'm going to give you a minute at the most. Go.
Yeah. Nuclear. Oh yeah, it's we got jail.
What's that?
Is chemical energy wind energy, or does it actually have to be stored?
Semantics. So if you like to argue semantics, well, maybe I'm not chemical energy. Break the bond.
It's no longer.
Isn't everything what? No. I mean, there are a lot of things that have chemical energy in them. That's true. Thermal energy, electromagnetic energy, nuclear energy, elastic energy.
Wait, Miss Beverly.
What?
Gravitational energy.
No, there's a kind of energy. Yes, that's yes.
Okay.
No, because there are lots of different kinds of potential. That's the distinction. That's part of the reason we do this. Have this conversation. Yeah. All right. It has been way more than 1 minute. It's probably been almost 2 minutes now. Jeez. All right. So let's talk. Then we're just gonna do this quick. Talk to me here. Thermal energy. What do you say? Is it potential or kinetic? Kinetic? We agree?
Yes.
Want to fight about it? Why do you say kinetic? Molecules dancing around, right?
Yeah.
The more thermal energy they have, the more they move. Electromagnetic radiation, light, it's all the same thing, and it is what? Kinetic or potential? Kinetic. Thermal energy is really just electromagnetic energy at a different wavelength, right? So really all of this is the same. Thermal and electromagnetic radiation, light, all together. All right. Solar. This is one where we can argue both ways. Yes. Tell me why you would say that solar energy is kinetic energy. Because it's just electromagnetic radiation, right?
Yeah.
If that's the part of solar that you're talking about, like literally the energy coming from the sun to the earth, absolutely, that is electromagnetic. Boom, we're done. That's kinetic. Argue for me that solar is potential energy.
Because it's just being stored.
So you can dig it on either end, right? So you can talk about it in terms of the energy once it's been absorbed, right? Yep, the solar energy. Yep. Or you can talk about it in terms of when it's being created in the sun. There are lots of different ways to do that. So I would argue that this one's there's a lot of physics in here. We'll take them both. Nuclear.
I don't know. Potential.
It is potential, yep. There's a lot of potential. If you break that nucleus apart, it goes boom, right? And then that stored energy inside that nucleus can turn into some thermal energy, right? So that potential is being turned into kinetic. Another one that we did not include here is atomic energy. Okay? You said it, but you didn't say it? Oh, come on. If he was on your sheet, it should be on my board, friends. Come on. All right, so what is atomic? Kinetic or potential? That's what I want to know. It is also potential, yes. Chemical?
Potential.
Chemical's a whole lot of potential energy. Potentially.
Does atomic energy consist of nuclear and chemical energy?
So like, if I'm an atomic physicist, I don't care all about nuclear. If I'm a nuclear physicist, I don't care at all about the atom, right? Like, so they're smaller and smaller pieces, right? But that goes back to the argument of why don't we just talk about it all as kinetic and potential? Because that's really what it is. It's all kinetic or potential. But there are different subsections that you might want to study and not study the rest of kinetic. You just want to do this thing. Yeah. So that's why we have this conversation, because there's lots in there to talk about. Elastic.
What is that?
That's a good question. What is that? Who said elastic? Was that you, Liam?
No.
What is elastic potential energy? What is elastic energy? Give it away. Where does it come from? Yeah. So if you take your rubber band, right, and you right, you got a bunch of stored energy in there. You let it go.
So is it both?
No, so it is potential. That's why I slipped up and said that. Yeah. Elastic is potential. Hydroelectric. What's that? Same as solar. It depends on which part you're talking about, right? If you have a bunch of water sitting behind a dam, okay, that is a whole lot of potential energy, right? Once it goes through the turbine, then you can say that that's kinetic because it's moving and it's also generating more potential. So that one I would say you can say both ways, potential or kinetic. Geothermal. Why do you say kinetic? Because it's thermal, it's just in the earth. Yeah, I would say so. Mechanical energy? What does that mean?
What you're doing. It's like
It generally is associated with kinetic energy. Sometimes we talk about mechanical energy being just like objects moving and relative placement. Most of the energy that we're going to talk about in this unit is mechanical energy. Okay, so this one has kind of a fuzzy definition. Wind. Movement of air, right? Sound. Movement of air, yes, or of other things. Internal energy. What does that mean?
like side zero.
Have you ever seen this equation before?
Oh my god.
Yeah? This is the energy associated with any mass, right? So you have energy. You are really just a big lump of energy, right? Based on your mass, you can figure out how much energy you have. This is what kind of energy is it? Potential or kinetic? Your parents are right. You have a whole bunch of potential, right? It's a whole bunch of potential. That mass can be broken apart. When you break it apart, boom, things happen. And yes. So that is potential energy as well. Biomass. Potential. Gravitational. Potential. Carbohydrates. Potential. ATP. Potential. Oh dear. All right. So there are lots of different kinds of energy. Many of these are things that physicists study. Some of them are things that we kind of like, we'll just let other scientists do it, like ATP, carbohydrates, biomass. Like we do a little biomass stuff, I guess. But a lot of this stuff is stuff that physicists do. The things that we are going to focus on in this class, in this unit, are specifically kinetic, kind of from a big picture perspective. We're going to look at two specific kinds of potential, and we are going to look at thermal as well. Okay, so those are the ones that we're going to focus on in this class. Elastic potential, gravitational potential, thermal energy, and mechanical, what I'm going to call kinetic energy. Okay, we are... No, that's not what I was going to say. Good try, though. We're gonna go back and talk about the frog again. Because you missed him. Can you what?
We name him.
No. He's just the frog. Okay, so I've got a frog and he's gonna be sitting here and I want you to tell me, we're gonna do kinematics again. Because it's been a while, we haven't done it for a while. We're gonna do kinematics and I would like for you to find an equation, okay, relating his initial velocity, final velocity, how far he falls, and the acceleration that he experiences. Do you have an equation for that?
That's the calculus one.
Did you find it?
Yeah, we got it.
What you got, Henry?
Final velocity squared is equal to initial velocity squared plus 2 times acceleration times the.
Yeah? Everybody happy with that? You can say no.
What's this? Is that 2 VIs or what is that at the beginning? No. Over.
Oh, that should be an F.
Okay.
I just was going too fast. I was getting excited because people said that they had things, and so I didn't want to, yeah.
Back to kinematic.
Yeah. I'm going to rewrite this just because I'm trying to move kind of quickly here. I can say that D, I think on your equation sheet is written as delta X, right? Or a change in position. I'm going to write it as a change in position because I have my frog. He's going to start up here, and he's going to drop down to the floor. So there he is at the bottom. So I'm going to have the position final minus the position initial is equal to, is this okay with you if I have V final squared minus V initial squared over 2A?
What's the Y?
The position 1 and position 2. Final position minus initial position. On your equation sheet, it has X's, but I'm looking at it in the Y direction, so I'm just changing it to Y. Is that okay?
Yeah.
Position in the Y direction. I'm going to do a little more algebra if that's okay with you. We okay? I'm going to multiply by A on both sides. So I've got A. Hold on just a second. Yes. Times YF, final position, minus the acceleration times the initial position is equal to, I'm going to write this as 1/2 VF squared minus 1/2 VI squared. I did a lot of algebra there. Tell me if that's okay. Courtney says it's okay, but I don't trust her completely, so let's make sure. Are you guys okay with that? And then because I want to and because I can, because I'm allowed to multiply everything by the same thing, right? I'm going to multiply everything by mass. Does his acceleration depend on mass? Does his final velocity at the bottom depend on mass? No. Like all this stuff doesn't deal with mass, but I'm just going to throw it in because why not, right? Like something to do, and because it matters for what we're going to do now. So I'm going to multiply everything by mass. Here it comes. So I'm going to multiply by mass here, and I'm going to multiply by mass on this side. Okay. And then I'm going to ask you also, what kind of acceleration is the frog experiencing?
Negative 9.8.
Negative 9.8. And if I'm lazy and don't want to write negative 9.8, what can I write down instead?
Negative.
What's the letter? G, right? So I'm just gonna add a little tail to that. So I'm gonna write this as the final position. Oops, excuse me, hold on. M times G times that final position minus M times G times the initial position is equal to, that's going to be 1/2 M times V final squared. And this is 1/2 M times V initial squared. How are we feeling there? Are we okay?
I still don't understand why you put the mass in there.
I will explain to you why. So the short answer is because I can. Because I know that what I want to see is what's interesting here. Is that okay? But the long answer is just to confuse you.
Just wait.
Just wait. There's more. Okay. I'm going to put all of the, Hold on. I didn't miss a negative sign, did I? Nope, I think I'm okay. I want to put, I feel like I missed a negative sign. How did I do that? Oh,
Do you want to know?
if I have to make sure this makes sense to you and to me as well. The height here, the final height is going to be smaller than the initial height. Does that make sense? Yeah. So I'm gonna flip this sign here just to make my life a happier thing. Okay. And now I'm gonna put the initial stuff on one side and the final stuff on the other side. So I've got mg, the initial height, plus 1/2 mv initial squared, mg final height, plus 1/2 mv final squared. And I'm going to underline this little guy here. I'm going to underline this little guy here. And I'm going to note that they're very similar. That is the algebraic representation for one kind of energy. Energy of position in a gravitational field. Energy of position in a gravitational field, also known as gravitational potential energy. And on your equation sheet, how they describe it here. We're just going to write it as U. So I think that's what they use in your book. This other kind of energy that we came up with, it has a velocity in it, doesn't it? Yeah. Velocity, or the energy of motion, the energy with velocity is called, what is it? Kinetic? The energy of motion, that one is going to be marked K. All right. This equivalency is non-trivial, and we're going to come back to that later. But for right now, I just want to focus on these two definitions. I presented it this way because I'm hoping that at least some of you have seen these equations before. Have you seen that, or are these brand new to you? Really? Did you not do this in foundations or anything like that?
We took foundations.
You didn't take foundations? What did you take? Earth science?
Sorry, Gia took foundations.
Oh. No, he didn't. Okay. Well, this is brand new then. Okay, good to know. Whatever. It doesn't matter to me. None of you took foundations. Interesting. Well, you missed out. Now you know. Now you know. So you're going to write these things down. I'm going to give you a ranking test to look at for a minute here. You didn't finish writing? Oh, you're whining a lot, though.
That's really. Let's consult the corner, whatever.
There you go, Harrison. I got it written down. All right, friends. We've got, like, what, I don't know, 5 minutes. Hot diggity. Let's keep looking. Let's keep working. You can get out of here. We'll miss you. All right. A cart with a spring plunger runs into a fixed barrier. The mass of the cart and the velocity just before impact with the barrier and its velocity right after the collision are given in each figure. All the velocities before the collision are given as positive. Since the cart is moving to the right, and after the collision, it's either moving to the left or negative, or indicated with a negative, or it's at rest. It says rank the change in the kinetic energy for each cart. Can you do that? Yeah, go ahead and do it. You can talk to your table mates. That's fine with me. Talking to your table mates is cheating?
So,
VIs.
No, that's not questions. Okay, the first one. I'm trying to but it's velocities.
Oh.
Yeah, we'll talk about that. But we're not talking about it today.
I mean, yeah.
Velocity 1/2 minus 10.
Oh.
25 times 5.
You do okay for me?
Yeah, well, ooh.
What realization did you just come up with that scared you?
I don't know. So, are we supposed to use like change in velocity, or isn't that just
Change in
VI?
kinetic energy. This is why we're doing this problem.
You know, have like a spread.
It says 4.
It says right the change in.
A is greater than B, same as D is greater than C.
Okay.
16 times 10 divided by 2. Wait, would it be
Nick, do you want me to make that a little bigger? Would that be helpful?
Nine 45.
Oh, yeah.
We got it.
Henry, dear, there are still people that are working. Just because you're done doesn't mean everybody else is done. So if you could let them.
So the change, right?
I would like for you to write down your answer on your paper somewhere. Okay? Your homework for today involves calculating kinetic and potential energy. Okay? That's it. Finding a velocity from a kinetic energy. It's all stuff that I think you should be able to do. And the homework is on Canvas, so you can get it there. Okay? If you have any issues or questions, you know where to find me. You know where to hunt me down. If you wanted to come in to do Liberty Time corrections, you are welcome to do that today or next week or sometime when you're free. That's fine too. I need to write that. Come in. Yep, that's fine.
So for a retake, I have to do test corrections first and then a retake, right?
Yes.
Okay.